looking more at our own respiratory system, of course, coming in with the nose. Nose has a lot of things, the nose hairs, the mucus, things like that, to help filter, stop any dirt, other stuff in the air. And also, as the air first comes in, encounters those, it gets, if the air is cold, it gets warmed up, matching more with body temperature. And also that air can pick up some moisture and get more like the moisture that we'd like to have in our lungs. The air then will go on down in through our trachea and into the lungs. You have finer and finer branches out into the little air sacs, the alveoli. And so the alveoli have very thin covering next to the capillaries. This allows oxygen from our air coming in to go into the blood, and the carbon dioxide from the blood to bubble out and be breathed out again. Breathing. This is actively pumping the air in and out using our lungs. Mammals, we have a big diaphragm muscle under our lung. And so contracting the diaphragm helps squeeze the lung, push the air out. When we relax, the ribs expand, pull back the other way, and have the diaphragm ready for the next breath. If the diaphragm gets low out of whack, then you've got hiccups. Okay, we get oxygen. Now we need that to travel through the body. And so we have a variety of specialized molecules that hold on to oxygen. And these typically have color, at least when they have the oxygen on them. And so they are referred to as respiratory pigments. But of course, grabbing the oxygen, we then need to have it let go of the oxygen when it gets to the other parts of the body. So it needs to be something that can hold on to oxygen, tight enough to carry it, but loose enough to release it to the rest of the body. So, for example, in our red blood cells, we have hemoglobin. It contains iron, which is what actually attaches to the oxygen. And characteristic of vertebrates and some invertebrates as well. For example, the blood arc is a clam with hemoglobin, and so it's very red in contrast to most other clams. Hemocyanins, instead of iron, have copper. That's what directly is hanging onto the oxygen. This is found in a number of invertebrates. A lot of mollusks use it, a number of arthropods as well. Myoglobin is a different protein related to hemoglobin, but myoglobin grabs onto oxygen better than hemoglobin does. This is very important because your muscles need oxygen. If the blood's hanging onto it, that doesn't help the muscles. So the muscle need to have a protein that can grab the oxygen from the blood and hold it in the muscles to be available to the muscle. Most other tissue, they're not using oxygen nearly as fast as the muscles are because they're not as active there. And so just the diffusion release of hemoglobin into the low oxygen of the tissues is enough to supply it. They don't need something like myoglobin to help actively grab onto it. But there is one situation where all of you needs to be very good at grabbing oxygen, and that is when you're trying to get it from somebody else, namely mom. As an embryo developing inside the womb, the baby needs to get oxygen from the mother's bloodstream in the umbilical connection there and get it to itself. So unborn baby hemoglobin is better at grabbing oxygen than standard adult hemoglobin, and so it's able to get the oxygen from its mother and then carry that to its tissues. Carbon dioxide can attach onto these to some degree, but it's also pretty good at dissolving in water. So it can be carried along there. And also it can interact with water chemically and form the bicarbonate ion instead, and that travels in water easily as well. Breathing a lot's important, but sometimes you want to not breathe because you're underwater. Humans, it's mostly for fun, but there are some air-breathing mammals that spend quite a lot of time underwater, and they have specialized adaptations in their physiology, ways to store lots of oxygen and make sure it gets to the parts of the body that need it most, allowing them to dive more and spend more time underwater. For example, there's some types of seals that have much more red blood cells. They have very thick blood compared to what we have. All the better to have much more oxygen in their system. Breathing, that's getting stuff inside you. You want to be careful what goes inside you. And so there are lots of specialized protections there. For example, the hairs in your nose, they may look funny if they stick out, but they are helpful in keeping dust and bugs and other things from getting breathed in, going into your lungs. All the mucus, yeah, it's a nuisance when you sneeze all over things, but inside you, that's helping trap, again, germs and dust and whatever other stuff, and then that can be carried away, gotten rid of. Also, some of the chemicals in there help to kill bacteria, viruses, things like that. Their cilia also, as the cilia move, they move that mucus and whatever's stuck in the mucus and carried away, and then you can get rid of it. But don't try too much coughing in public. You might get folks a little worried these days. Also, that cough, that's from constricting muscles in associated with the tubes, the bronchi and all in your lungs. And that's useful in getting anything that's stuck out. Something that does get in the lungs, well, your white blood cells, such as the macrophages, can come in and surround things, carry it off. But if you're getting too many particles in what you breathe, all these systems may not be able to handle it. One particular situation is getting a lot of smoke that you're breathing in, whether it's from being around a fire or from smoking. And these are harmful to the lungs, no matter what you're smoking. Air pollution, another big player. Air pollution is actually a major global killer, especially in countries that don't have good regulation, but can be quite a significant problem for good breath. Not just in city areas, actually, a lot of the problems due to pollution are not from a factory smokestack, but from the cooking fire that's in the middle of your hut. Smoke from that fire is in your hut. And if you're breathing that all the time, that's hard on your lungs. So finding ways to help people to have an alternative to having a fire all the time inside their home is a useful global health initiative. Probably quite familiar, but again, smoking is quite hard on you. Here we have a slightly better looking and a very ugly looking lung due to the effects of smoke. Hopefully a reasonably inspiring lecture there.